Hi, in this video I'm gonna show you the new version of my CNC controller, how to connect it to a Proxxon MF70 CNC ready and how to use it to engrave a plate with only a hand drawing. The controller was upgraded with a 10.1-inch LCD display and has sub-D ports on the back, which makes it a little bit more flexible. Here is a brand new MF70 CNC ready. The installation is plug and play. Just connect the three motor cables and also the MF70 spindle. Then turn on the controller and let it boot up. Double click on the bCNC icon, establish the connection to the Arduino board, and then you can use the machine. Drive the motors, for example. The MF70 CNC ready has end switches, so you can perform homing. The homing cycle first searches the Z end switch and then the X and Y end switches simultaneously. You can find your machine zero very easy that way. The installation with the CNC kit for the manual MF70 is as easy. I have shown you how to mount the motors in my first video. Just connect the motors and the spindle to the controller and you can move the axis. Now I'm gonna show you how to engrave this logo on a plate, and I'm only using a hand-drawn picture. First I'm gonna draw it on a white piece of paper. The logo is simply my homepage, Kofex.net. Kofex.net without www. Then I'm using the application Cam Scanner on my phone to create a nice and clear picture of the so drawn logo. Here it is. To get the picture on the controller, I'm gonna send it to my own email address. Then open my email account with the browser on the controller and download it to the controller desktop. Now I'm gonna jump to the controller screen. I'm recording everything I do on the controller with the program Kazam. The first thing we have to do is convert the JPEG to the DXF. I'm opening the browser Chromium and just typing JPEG to DXF in the upper bar. Then click on the first search result and choose the file. The file is on my desktop. Load it up and click Convert. When converted, I click Download and open the folder in which downloaded it. Here it is at Home Pi Downloads. Copy it to the desktop for better accessibility. Okay, this was the first step. Now open LibreCAD and you will see the logo. Open the file. Here it is. The size is way too big. It is 2800 millimeters in the height and I want this to be 110 millimeters, so I need to scale it down. Calculate the scaling factor. Then mark everything and go to Modify Scale. I'm gonna delete the dots down here. This is some dirt from the paper I scanned. Tools, Modify Scale. Click somewhere in the black area, type the scaling factor and click OK. So now it's much smaller. Now I'm gonna move it near the origin mark everything, then go to Tools, Modify, Move Copy, click on the first and the end point, and use Auto Zoom to zoom in. Now I will rotate it 90 degrees, and move it a little bit so the origin fits better for my milling plan. Okay, this was the second step. Now we can open the DXF in bCNC. Double click on the bCNC icon, open the file. Opening it takes a while because the file is really big and the bCNC converts the DXF into G-code already, which is very nice. Now bCNC has some trouble displaying it. It has to do with this, something to do with the screencast. So I'm stopping the screencast, opening the file and then starting the screencast again. And here it is, the complete DXF. We can go to the editor tab. You can see that bCNC converted the DXF in G-code. The code is structured in segments. You can see that the file is really big with a lot of circle comments. The other letters are below the K, yeah. Now going to the Control tab, establishing connection, and then I'm gonna move the gantry approximately where my XY0 should be. It don't have to be that precise for my plan. I'm clicking on the scan to see how far the axis will travel in this job and to be sure that there are no collisions because of the axis limits. Then I'm gonna zero out the Z-axis. I'm just setting the jog step to 0.2 millimeters and then move it until it touches the plate. When it touches it, I'm gonna set it not to 0 but to 0.5. This is the depth the plate will be engraved afterwards, because the G-code created from bCNC goes every time to Z equals 0. Then everything should be ready. Move the gantry up a little bit, turn on the spindle and press start. Beginning looks fine. It's always getting dirty, so a vacuum is not a good idea. But there are two things I do not like with this so created code. First, I have created always two lines close to each other. This does not look good and only increases the engraving time, so I'm gonna deactivate the inner lines in the editor afterwards. And also the order is not fine, so after the K it jumps to the N. And also there is some residue from the paper I scanned, so I'm gonna deactivate these points as well. Go to the editor tab and deactivate everything you do not want to be milled. Just uncheck the checkbox. When it is how we want it, we can start milling again. I have turned the plate, searched my XY origin, and this time I'm gonna let it engrave only 0.3 millimeters. Perform scanning and press start. Unfortunately, I did not change the order, so I'm gonna stop the job and set it right. It goes all the way to the end, which is not very efficient. Setting the order happens again in the editor tab. Click the segment you want to move up or down. With this function I'm having troubles with the screencast again. I'm gonna stop the screencast, arrange the order and then start the recording again. Here it is, everything is in the right order and no unnecessary engraving is there. Then go to the control tab. I'm gonna engrave a little bit deeper, 1/10 of a millimeter deeper, and start the job again. The last thing is the outline of the plate. I'm gonna mill this via comments in the comment line. The plate is 1.4 millimeters thick. I'm gonna mill 1.3, so leave a little material beneath. And I'm simply typing G1 comments and doing the job. I'm letting a tab here so the part won't fall out. I could do this with the jog buttons, but I can't set the speed there. And actually I have made a mistake. I did not calculate enough space for the outline, so we have a collision with the x-axis. Now we have the collision, but it's not too bad, I can finish the part anyway. And that's basically it. Then just to break out the part, I'm using my pliers, and I'm totally out of focus here, sorry for that. Do some finishing. And here it is, from a hand drawing into an engraved plate. Thanks for watching and have a nice day. Visit my homepage if you have some spare time.